channel, instead of spinning an electrolyte through a magnetic field, you could spin gallium or any liquid metal through a magnetic field, and you can get what I call a fluid turbine. It's a Tesla fluid dynamo. Sorry, I always call it turbine, but the dynamo would be two magnetic fields. I showed it on Nathan's channel whenever I first. But if you use liquid gallium and spun it above this magnetic field, it would act like a Faraday disc going above a magnetic field, and you get a really high current. And what me and Sean are trying to work on is how to increase the voltage of that current, because you could do it with electrics very easily. And then you have a hybrid system that's high current, high voltage, and then
you fry your eggs on it.
I wish I had the actually YouTube. I would put like the fireball by your eggs.
No, but I did the same, and it creates a gravito-electromagnetic field that shifts the gravitational acceleration. So it shifts the weight of the apparatus.
Have you seen what's his name with the SR3B or the TR3B? Have you heard about that?
Yeah, the Lockheed Martin TR3B
Aura.
Yeah.
That's the TR3A, I think the Aura was. The TR3B.
Yeah, you're right.
Is
the B, the A was Aura, and the B is, I don't know.
The B supposedly uses both T. Townsend Brown's electrogravitic charge, but also apparently the three red plasma balls or whatever that are seen on it supposedly are acoustic, somehow acoustic generation of anti-gravity.
I think they're buoy balls.
Yeah, it's just some sort of plasma, high energy plasma that creates a gravito-electromagnetic field that shifts the weight of that creates a differential in the energy potential, which will induce a force.
And to be able to potentially make a dominant monopole that's positive or negative is cool too, because you can't do that with magnets. That's what separates the invention. Because you can have a dominant positive charge or dominant negative charge using the knowledge of that. And you can't do that with magnets. But you can literally have a positive and negative pole. Dominant. Not totally.
Yeah, you're talking about canceling energy, or?
No, I'm saying when it comes to energy, we can define it as the electron volt on the quantum level, right? The electron volt literally is a charge voltage product. Yeah. So the energy is equivalent to the charge and voltage. Okay? That's potential energy.
Yeah.
Of the electric field. The energy of a magnetic field is different.
The energy of a magnetic field is the energy density is the magnetic field squared divided by the permeability of
in engineering, it would be Li squared. So yeah, I would say, but the L is the inductance. Yeah. When it comes to electrical engineering, that's all I really relate things to.
You're an engineer?
Yes.
Oh, cool. Electrical engineer?
Mm-hmm. Yeah.
Oh, nice.
I have a bachelor's, and I've been studying this for 20 years,
Just the mechanical engineers know a lot of stuff, so
yeah,
electrical engineers are kind of even better.
Yeah, it's fun because it's not thermodynamics, it's electrodynamics. It's completely different. Mm-hmm. And to have an electorate is going to change the world, just like the magnet. And I'm just saying, to have these combinations that are available, and if I could work with Mike Faraday on his cell, we'll make as much power as we need, guys. You want to power your house, me and Mike will work together and do this.
Are you next to Toronto?
I'm in Georgia.
Georgia, yeah.
Yeah, you're about
Georgia.
3 hours away from me.
The
3
swing
hours.
state. The famous swing state.
I never
That's
heard
a
that.
3 hour. So what? A 3 hour flight from Toronto to Georgia.
Oh yeah. But we don't have to be in person. We can,
Oh yeah, we do on Zoom call or whatever.
that's what we're best at, anyways. I mean, we've been doing it, so.
Yeah, it's we'll definitely chat offline for sure.
Can I know you guys already seen my experiment, but can I show
Sure.
I show him my the experiment I did about the equipment, the MHD vortex?
Pop it up.
Just one sec.
Great.
Can you see my screen?
Yep.
Yeah. Ah, man. So look on the right. You're gonna see the weight of the apparatus shifting right there.
Mm-hmm.
Yep.
Now I turn it off, and it's.
You did this well over a year ago, I think, right?
Yeah.
You did that, Phil?
Yeah, more than a year ago.
That's cool, man. I like that.
Was this one of the ones you presented at APEC?
No, I got sidelined at APEC exactly at the moment where I created that stuff, and I figured the strong nuclear force and things like that. Tim decided to go all mainstream, so he can even if we ATM people started APEC, we kind of got sidelined in favor of mainstream people. So,
hey Bernie, do you mind me asking why you protested APEC that time? And I had your back, dude. I was in the chat with you, like, hey, if Bernie doesn't like this, I don't like this.
Yeah, it's exactly what Phil's stating, and we discussed it a few weeks ago too, and agree also with what Nathan and Mike feel of how it's like they just take the ideas from presenters, sideline them, and then try to kind of claim them as their own, while simultaneously anyone with real breakthrough stuff, they just push off to the side, it seems, lately.
I think this is the best way to do it.
Not only that, they got the guy with the sweater that bores you to death with the fireplace. Oh my god, dude! I can't sit through that, dude. I turned it on and off several times last time, and I just couldn't do it. I kept falling asleep.
What? I mean, it's hard to keep your attention. I mean, who wants to sit there 4 hours of like where you're like, dude, is that really the best you got? Like, what could thrill me at least? I mean, give me something. But there's nothing at the end of 4 hours, and you're just like, dude, I just feel like I wasted 4 hours.
I'm curious about something. Why are they not recording anymore the stream, like the Zoom meeting, but the
I don't know. I offered to do so, and they said no, and I don't know.
Well, I'm there with you, man. I'll protest, Bernie. Are you still against it?
And I think it's too many egos.
Yeah, I just hope that they reopen up the platform a bit more. I guess they were attacked by a bunch of trolls or something at one episode or one session, and then they closed it off and have limited a whole bunch, and it's not the same as it used to be, and I just hope that they reopen their format more.
Or we can just keep doing this. and like blow APEC away, because this is the real engineers. I haven't met any other extraordinary inventors in the league.
Yeah,
You know what I mean?
we.
Nobody else is doing what we're doing. I mean, APEC can do APEC, but like this is like a group of real engineers working together and making it happen. So
Well, it's, we're not basing all our stuff on ego, trying to make the mainstream media, right? We're just trying to do our own thing. And
Yeah, that's why I like working with engineers, because there's no ego, and if it works, it works. If it doesn't work, it doesn't work, and you have the ultimate, and you have the ultimate last word. The theoretical physicists can say whatever they want, but you're the one who's gonna find out if it works or not.
yeah, experimentation will always trump the physics.
Yeah.
yeah.
Well, I
Physics
have a
comes
theory
later.
I have a theory on why they split it. One is being recorded and broadcasted to the world. The other one, they're just stealing ideas from, and there's no proof of it.
China?
That's the truth, because look at the people that are on the
China's gonna
live
take
one
my shit.
and
China's gonna
people
take
that are not on the live one.
Lulu knows a lot, because she's
Can
on
you
the
gentlemen
many
hear me?
shows. Yeah.
Yes, ma'am.
Mike does.
Oh, thank you. Thank you very much.
Ooh, Winona
Right on,
Ryder's
man.
back on,
Okay.
dude. Dude, I had to call you,
What's
dude.
up?
I know your name's Winona Ryder, but I assume you're a dude. I'm just gonna call you.
Thank you, man.
Thanks, dude.
Yeah, live chat is alive and well. That's what I like about our show. We have a really good active chat board, and welcome anybody that's new that comes to the channel. Welcome to our show, and this is who we are.
So good.
We're trying not to be egocentric maniacs. We're just inventors that like to shoot out ideas and share our ideas, and hopefully that can help one of our other followers advance in their stuff. That's what this is all about, right?
No, but that's exactly what I said to Jack Sarfati this week. I said, I told him that all he cares about is selling books with his and disinforming the population with his nonsense. And proof is he wouldn't bet $5 on his experiments. He wouldn't, because he knows it's not gonna work. It requires exotic energy and all that nonsense. So he clearly knows it's never gonna work, what he's talking about. So he wouldn't spend $5. He can make all the calculations he wants. But
Could I offer an experiment off my physics that would work? Maybe. What if Sean makes this electric pendulum, and can a control neutralize weight to swing it, but like a positively charged electric and a negatively charged electric compared to the neutral swing? Do you think there would be a difference in the time of the swing? I think there would be, because the Earth has a more abundant negative charge, and if it's a positively charged pendulum, it would have more acceleration towards that. So I think the positive pendulum would tick faster than the neutral, and I think the negative pendulum would tick slower. And that's
you're right. The Earth has an electric field, so it's gonna
when it comes
affect.
to physics, the power is prediction. You know what I mean?
Yeah.
When it comes to potentials, no matter what, the more positive potential is going to feed the lesser potential. No matter what.
Potentially.
No matter the circumstance or material or whatever, the more positively, the greater, not positive, I shouldn't say positive, the greater potential is going to be the source to the lesser potential, no matter what the circumstance.
That's why it'd be interesting for a pendulum just to see. I
By the way,
predict-
hi, Mike.
Hey, what's up, man?
Nice to see you, man.
Well,
Yeah, no cameras. I got
it is good to see you.
He's still in the holly deck.
If my
Mike?
picture's not good enough.
It's 3 holes.
Gives me every time.
You'll never live this one up. Especially.
Oh, we played the episode with you in it today, Mike. With the big toroid, the giant transformer you had with the 6-inch hole. Remember that? He's all proud of it, showing it off, putting it right on his head, and he's got this big hole.
I mean, coil.
Yeah, awesome coil, by the way.
Yeah, the big hole coil.
Yeah.
Oh, I got something to show you. I don't know if you've seen this.
12-inch diameter.
So you're going to talk a bit about the diode aspects, right, Mike, and how it's crucial in engineering.
Well, okay.
Flying.
Tesla did it first with the selenium diode, okay? And what he did is he made this selenium panel, like a big selenium panel, aimed it at the sun, and cosmic rays would evaporate the charge off. And that's the photoelectric effect. And Einstein took the Nobel Prize for that, but Tesla made it, okay? He took this big-ass selenium panel, aimed it towards the sun, and made a diode that way because it's one way direction towards the sun through the selenium panel. We would call it a solar panel, but Tesla was the first one to show the photoelectric effect when we say that Einstein got the Nobel Prize for the photoelectric effect. But Tesla discovered it. Cosmic rays.
Oh,
That's Mike's big hole.
Oh, got a mighty big hole there, Mike.
Mike, you're muted. Faraday, you're muted, sir.
This thing weighs like 20 pounds or more, 25 pounds. This thing's heavy, man.
That's a heavy hole.
Look at that heavy hole.
You could use that for a workout.
Yeah, you could work out with the damn thing. It's heavy.
Is that like true barium or no?
This one is a ferrite core, heavy as all hell.
But not barite. But that's okay. I mean, it's hard to find barite, right?
Yeah, this is a monster.
That's dope, though.
Oh, man, did your hand fit through that hole?
Probably.
Are you gonna make? Oh, you're making
Let's
him
do
fist
it.
the hole. Oh my!
Oh my gosh!
Mind you, I have a very big hand, so.
Oh, the very heavy hole.
Some people bigger than others, huh?
Yeah.
Yeah.
Oh man.
What if you put like gallium or mercury in the center of that hole while operating it?
Actually, know what I have done. I put my Tesla plasma ball and rested it right in the middle of the toroid, and I was able to light off light bulbs with all these leads.
Were
Oh,
they
nice.
LED? Were they LED or
Yeah, either or. Yeah.
okay?
So
Incandescent? Could you do incandescent?
If the plasma ball was say 5 kilovolts, maybe. But
That's
the one
dope.
I have,
Yeah, that's where you really test, though. You know, if you're really extracting.
But yeah,
stuff.
like they're groups in 2,
That's
so
cool.
I got 1, 2. There's
That's
four sets coming off it, and I've got them all labeled. Which one's more powerful than the other? You know, the resistance and all that. So I could hook it up to any of these leads, and if I had the plasma ball even just beside this, it picks it up.
You know, Mike, I got one of those. I pulled it out of a speaker. It's just not as big as yours. My hole is much smaller.
I got the biggest hole of them all. Oh my God, sorry.
Like
Going
a
off
holy
the rails,
rollers in here.
man.
I'm sorry, man. I got to make some jokes, dude. I've had a hard day. I burned my mouth off today on some hot wings.
Yeah. Take a screenshot of that.
Nathan was a trooper, man. He's it. Like you said, you got some blue eyes to tame it down.
Oh, gee, it was bad.
Have you guys seen where they do 2 wirings on those with the ferrite core now, but separately halfway? And apparently by having them 50-50, you can actually like pull some like extra
You're
energy
mirroring
out
it.
of it, something like.
So if you had 22 turns going on one side and then 11 and 11 on the other, the amount of turns are the same, so they resonate back and forth to each other like a mirror. But the beauty of splitting it on the opposite side is you can use the 11 to go run off to your regular system. Then the other 11 is a multiplier. It's in addition to it. So what you're doing is you're making a half wave.
Yeah.
You know what I mean?
half-wave.
Yeah, in the whole thing, and you're able to pull the energy for free. It's
Yeah,
called
the other-
a bit.
Right, a bit transformer. Yeah. So what you want to do too, the one that is your half wave, you want to go to a bigger gauge wire, and you're gonna wind it in the opposite direction of the one that's drawing power into it. All right. So what you're gonna have is a decrease in voltage, but your amperage is going to go through the roof, and that's what Don Smith was working on. This is all what ties in what he was doing.
But on a ferrite core, though, I want to say this. I don't think it's working exactly that way. Don Smith was working with coils, which it worked perfectly to pull out the amperage. But the ferrite core, because of the way it is, I don't think it's going to give you that.
Yeah. Yeah, because I know he worked with toroid cores like this. He made one device that had 2 of them. Not as big as the one I had. I think they're maybe about 4-inch diameter. This one here, I think, is 8-inch diameter. So it's hefty. It weighs a friggin' ton.
Yeah, it's, you know what? Where you find that toroid, by the way, in that configuration is in the Jewel Thief circuit.
Yeah.
That's where you're going to find it, because you're all about saturating the core at that point, and then it's resonating back and forth. When you hit that resonating mark, then you can amplify things. So I found it in the Jewel Thief.
Yeah, definitely. A lot of you can. I played around with this thing quite a bit, especially with even with the Renegade device. I was actually able to split the power off and get more. 2 channels with the same amount of potential coming out of it. Right. So right there, that's over unity right there. If you're splitting it and still getting the same potential off each channel, then yeah, you're ahead of the game, right? But yeah, the plasma stuff I was doing with this, actually, I was surprised it worked as well as it did.
Well, yeah. I mean, it runs through there pretty good. You actually probably get a conversion out of it. Just putting a voltage field in there, like a potential, and it'll probably pick up amperage because of the toroid.
Yeah, because it's a closed circuit, so it's just going to hold that electromagnetic field. It's different with if you're using, like, say, a solid rod ferrite core versus a toroid. A toroid is a closed magnetic field, right?
It's closed circuit.
Hey, Faraday, do you mind if I ask you a question?
Sure.
What do you think, like a Mylar balloon, if you were to spray it with some of that carbon conductive or nickel conductive spray, and then like sprayed it with some vinegar, like as an acid, and then send it up as a balloon with like an aluminum wire attached to the earth? Do you think the evaporation of the vinegar on the balloon would increase the current from the balloon earth path?
If you're using graphene, you won't need it.
Well, do you get what I'm saying?
Yeah, I understand.
You could also do it with sodium carbonate or whatever alkaline you wanted to try. You know what I mean?
There's another
you're spraying the outside of it and then lifting it up to get the potential and seeing if the alkaline spray around the outside or the acid spray around the outside will give a current that's stronger with the potential because it's evaporating off into the atmosphere,
Right.
so it's pulling the current through the earth if you sprayed it.
Yeah, that'd be an interesting experiment.
Right? Doesn't that sound cool?
Yeah, like
I had like this idea of like a fishing rod where you'd be like, you know, there's old fishing rods where you hit the little button and like let it fly out. So you just hit the little button and let the balloon go up.
yeah.
And you charge these bobbins. And when you fish, it's cheating. This is like if the power goes out and you need to eat. You can make these shock bobbins where the fish will bite it and they get shocked and come
Shocked.
Don't do this because you will be arrested and it's cheating.
Kind of like dynamite fishing.
Yes, do not
the
do
same thing.
M80s. Don't do that. That's not cool. You know, it's survival only.
Yeah. Get the Canadian Parks and Recreation on your ass.
But yeah, it would be a fun experiment, like with a fishing pole. But you have to have like the reel made of aluminum wire or something light.
Yeah.
Take the mylar up, and then test between.
Yeah, what I like to do is get a helium balloon, like you're saying, and spray the outside of the helium balloon with graphene spray.
That's what I was saying. Like spray it and then put like an alkaline or an acid coating on it.
Yeah, bring it down to a gram potential, and you can run like an atmospheric motor.
Mind if I ask Jarvis a question? What do you know about this acid and pH values raising altitude, and what's your concept on that?
Think of alkalines as electron donors and think of acids as electron acceptors.
Okay.
Acids like to absorb electrons. Alkalines like to give up electrons and become earth metals. You know what I mean? Alkalines are more earthy metals. Okay.
Actually, Jarvis, know what you could experiment with? Ultrasound gel that they use when you get an ultrasound. It's a gel. It's highly conductive.
Mm-hmm.
Put that on the surface and see what happens.
So wait, if acids like to receive electrons, is that correct?
Yeah, acids have a potential to be like a sponge to electrons, and alkalines want to give them up readily. Especially like bentonite clay is a naturally negatively charged clay, so you can use ceramics too that are naturally negatively charged, and then you use an alkaline to knock these electrons off because they want to go. Nature is not that difficult. Nature does its thing naturally.
So correct me here, is the higher the altitude, the more protons you're
more positive compared to Earth.
Yeah.
And the lower the altitude, you're reaching electrons.
Yeah, it's approximately 120 electron volts per meter.
Wait.
Yeah.
Hold on.
Approximately.
The sun is the protons, right? Right.
Protons can be alpha particles,
Well, the sun doesn't release electrons, does it?
Yeah, the sun is an alpha part. Like Helios literally was the sun's name, and helium is named because the sun emits helium.
Well, helium is a hydrogen
in a positively charged state that's called an alpha particle, and that hits our ionosphere and strips away our ionosphere and makes it positive.
But isn't helium a hydrogen type?
This is like Tesla wrote a book on gravity, and this is like, The
question, isn't helium a hydrogen type?
Helium, if it's stripped of its 2 electrons, is an alpha particle. Yes.
Well, I mean, that's not the question. Hydrogen type is hydrogen. It's based off hydrogen. Helium is a form of hydrogen.
You asked about helium. Helium, yeah, once those 2 electrons are stripped.
Helium turns into hydrogen, or vice versa.
It turns into an alpha.
Well, me and Jeremiah were able to replicate a process of transmutation that turned hydrogen into helium. But yeah, helium is double hydrogen's atomic mass.
Right.
Yeah,
and it doesn't. And
ionized
get
helium
back to the protons
is
now.
an alpha particle.
And getting to protons here, hydrogen is proton based. It's primarily protons. No, I mean there's not a lot of electrons.
Hydrogen's a single
One
proton.
electron.
Correct me if I'm wrong. Is there a lot of hydrogens in protons or is there a lot of electrons in protons?
There's
Because
one
I'm in the-
proton.
I'm in the-
One
in the
electron in
understanding.
hydrogen.
So say that again.
Hydrogen is one proton and one electron.
Oh, so it's even.
Yeah, if you got
No.
deuterium, then you got a neutron with the proton with an electron on the outside, but that's the deuterium. And then you get tritium isotopes.
With two.
going up
Deuterium is more protons, less electrons. Is what you're saying.
man.
No, neutrons. The protons stay the same.
Deuterium, yeah.
The atomic
Well, neutrons are just irrelevant here because they're neutral.
Yeah.
No, neutrons are what form the isotopes of deuterium and tritium.
Tritium, yeah. See, Bernie, he's an alchemist, so he get like chemistry and alchemy is similar, and alpha particles are emitted a lot from the sun, and those are literally a helium atom that are stripped from its 2 electrons, and that hits the ionosphere, strips away the 2 electrons, and leaves the ionosphere positive.
What's stripping it away?
The
The electrons.
alpha particles that are emitted from the sun, which are helium. Helios is the sun. Helium was named after the emission of helium. Whenever hydrogen combined into helium and is released by the sun, it's literally helium, but it's particles that are positively charged called alpha particles.
And the
So can you see
ionosphere
my
is stripping
screen,
the electrons?
The
Can
alpha
you see my
particles.
screen, Joe?
There we
Why?
go.
So the ionosphere is stripping the electrons.
No,
So that's a hydrogen right there, Mike. And that's helium. You have 2 electrons rotating around 2 protons and 2 neutrons.
what happens is that helium atom is gone from the electrons and ejected out of the sun. So it has a positive charge overall. And when it
Right.
hits our ionosphere, it takes another 2 electrons to try to even out like this looks like. So as it takes those 2 electrons from the ionosphere, it leaves the ionosphere positively charged compared to the Earth's potential.
So the ionosphere is donating the electrons.
Yeah. The ozone layer has a lot of electrons. Ozone has
What's donating the electrons to the ionosphere? The Earth.
100 lightning strikes a second.
The Earth. Okay.
100
So
lightning.
that goes back to what I was saying. The Earth is primarily electron, and the sky is primarily protons.
I don't disagree, but I'm saying why. You know what I mean?
So you said acid absorbs electrons.
Yes, it's like a sponge.
So why would you put acid up there if the up there is primarily protons? You would put alkaline up there.
As an experiment, 2 balloons with 1 acid and 1 alkaline would be interesting.
Well, I'm thinking
I think we
the
need to
alkaline
try
would
that.
be the one, receiving the electron.
Yeah, you create a potential difference between the 2.
Oh, you could get the world's largest Jacob's ladder going on with that.
Yeah.
Just
Phil.
hope you have a very large capacitor bank to capture that stuff.
Philip,
Yeah, I'm just saying, like, why not try?
It's almost
One
like
could
the
be
Earth is
better than the other.
converting
I'm not saying
protons
way,
to
it's
electrons.
an experiment.
Philip,
Yeah.
what is the heaviest element you can model in your software? The one that what is the heaviest element you could do?
Be right back.
Good question. Let me check. The
Oh wow.
no, but that's I need to check the let me check the
I know gold is up there. Gold, lead.
yeah.
Gold and lead, I think, are right up there as far as the heaviest elements.
They're all radioactive, the heaviest,
Deuterium
but
is probably the heaviest.
Bismuth is cool too. I think bismuth is easier to turn into gold than lead.
No, I'm saying
They're all in the same line.
Oh, remember, you just said it. Remember, I was talking about that non-silicon based. It's bismuth. They're making the silicon chip with
Bismuth's
without the
really
silicon.
cool.
Yeah, bismuth and graphene.
It's
What is-
diamagnetic.
The heaviest non-radioactive one is called organicin.
okay, and what's one?
Interesting.
Organicin. Sorry, I missed the
So you could do.
terminology.
So
What's
you
the
can
atomic
simulate
number?
118. So you can simulate 118.
Yeah, but I don't think anyone's ever synthesized that. They have a very short half-life on that.
It's heavy.
No,
with
it's
potential.
not. It's not a radioactive element. That's 118 right here.
The noble gas.
Oh, okay.
All these electrons and protons adding to the heaviness of an atom is all just potential. So it's just potential heavy.
Energy density.
I mean, it's not real. It's potential. It's just,
Energy density. Energy is literally the charge and the voltage of an electron, like at a quantum level. All you need is charge and voltage, and electrons exist everywhere. So unless you say that electrons don't exist, I'll say that energy is free because I'm breathing in these electrons that are perpetually part of atoms that you can't destroy.
Electron exists, but it's not a particle. It's just a virtual
But
particle.
like free energy, I hate that because all energy is free. You know what I mean? Like what we get to exist right now is like breathed in by these perpetual motion little atoms going on. And
I forgot.
Well,
Well,
they don't exist.
It's like
Yeah.
breathing in air. Without air, okay, you have consciousness. If you don't have air, you're unconscious. Get it?
But
you have to consolidate
you-
potential
you-
to get heavy.
You'll agree with me that if you create, there's a lot of ambient energy around us.
It's
But if you
everywhere.
create-
It's free, dude. Everywhere.
We're
Yeah.
swimming in it.
We're
Yeah.
just like
When you look at most of space, it's just
but we
hydrogen.
can't
and Hydrogen
harness
is the
it.
most balanced.
we
one
can't
electron, one
harness it
proton.
because there's no potential. So we need to create a void, a real void. It's going to create a potential, like a differential, and then it's going to create a force we can harness.
that's
we'll
why
be able to create-
electrics will play a part that's different from magnetics.
Right.
It's all about consolidating
Yep.
the balanced potential that's everywhere into a smaller area.
Yeah. Either
Once
it's
you
like
start combining electrics, like the world's gonna be completely different.
See, that's why I made the power cell. That's exactly what we're talking about.
And that's why I want to work with you because I know where you're
Consolidating.
going.
So
I know where you're going, and I know how me and Sean can help. You know,
Mike is stealing our ideas and making profit of it.
Right?
I don't think so.
Oh,
But-
funny.
But,
how do
but you know
you
what?
use the bismuth, if you don't mind me asking?
Sorry, bismuth in
How do you use that?
what
In
in,
your
my
cell.
cell? I don't have bismuth in the cell.
Okay, never
But-
mind.
the
but,
diode is
this-
like a consolidator.
Sorry.
Well,
I went off
the
that.
diode, the bismuth, it can be used in. It's actually in that diode that John Hutchison was working with.
Gotcha.
Yeah.
Okay.
So you got bismuth, you got barium titanate, iron oxide, and there was one other element. It eludes me now. I'm trying to remember the name of it, but it was like 3 or 4 elements inside this diode, and with nothing going in it, it's not connected to anything. He was getting a quarter of a volt, constant
Yeah, dude.
potential.
Yeah,
I
that's
saw this
interesting.
guy. Did you see this back in the day, Michael? You probably saw this where he had this like black looking rod and he put 2 probes on it and it lit a light bulb.
Yeah, that's this
And
power
he-
cell technology.
I saw that.
Yeah, and he was saying it's aluminum bismuth alternating layers.
And he
Yeah.
also-
You can't find those videos anymore.
Yeah, they're
No,
hard to
I-
find.
Yeah, I got a couple of them. I was watching one today. He also has barium titanate wafers in there. They were, I believe, a 1/16 of an inch thick, and they were about 1.5 inch diameter. He had like 20 of them. It cost him like something like 30 grand.
Barium
Wow.
titanate is a really interesting electric material.
Yeah, I got tons of it. I've got barium titanate.
It's hard to get. That's awesome. You can get it.
I have about $3,000 worth of this stuff right now.
Well, I mean, Sparky Sweet thought it was cool, so I think you're on the right path, brother. I think like I said, if we understood what we're doing together, we could really do this.
One thing's for sure is these metals, you can't combine them without separating them with a neutral like carbon or something, because they could eat each other away, you know?
That's what I have in the cell, carbon.
I could say something, but I don't want to give away anything.
That's how they make diodes. They got the, one metal,
Carbon
then
wire.
carbon, then another metal of different metal, and then carbon, and then another metal of a different metal. And
I like
that's
the way
how-
you think, Mike, but I just can't comment.
That's how they get the energy to
Off-mind.
go in one direction, not back the other. They have to use less conductive metals from left to right as they go along, and that's in that same way. The perpetual energy diode can be manufactured. Technically, if you know how to combine the metals right, with insulating in between them, you have to. Or you don't have to if you're able to combine them in a way where they don't eat each other away,
Honestly, like, you're not going to just, I feel bad, but like, I've thought similar maybe 5 years ago. Like, and imagine me thinking what you're thinking now, where I'm at is close. And I congratulate you for thinking like that, man. But I can't comment on how I would do it. But just keep thinking about it and you'll figure it out.
Yeah. Well, what I'm thinking is you got to find the right, let's start with two metals. If you find two metals that don't eat each other away, now you got to find a third that doesn't, corrode the second, and then a fourth that doesn't corrode the third, and so on. And if you can layer them like that without a carbon insulator in between, that would be my thinking as the way to do it, because the carbon is going to.
How do you think the Earth does it?
Probably it's like that, yeah.
You think something similar?
I mean, there's carbon all over the place too,
Absolutely.
So I don't think.
But just like I always say, like if you think of something that seems more complicated than what the Earth can naturally do, you may want to rethink it, because the Earth.
Well, actually, I'm thinking the Earth is not actually doing the production of the energy; it's doing the conversion, and that the celestial bodies are creating sounds that do the vibrating, and that's what creates the energy, is the sound. And the Earth is not creating anything; it's doing the conversion. It's converting the sound into energy.
Well, when I say Earth, I mean nature in general.
Yeah.
Yeah, I just did a voltage test on this cell that I just made, the new design. It's putting out 2.52 volts.
Like the whole space is where the sounds are from. The combination of bodies out there, moving around or creating the sounds, that you can't necessarily hear, but they're there. And the Earth is converting those sounds into waves.
Is the 2.7 volt, is that a solid state?
Yeah, this is a solid state. Yeah.
I love the solid state. That's cool.
Converting the waves.
They measured Saturn's rings. They had this detector. They wanted to hear the sound of Saturn's rings. Saturn's rings were stable, but when they measured it, they destabilized the rings. So when they remeasured it, it was different from the first measurement. So it told them that by trying to read, the sounds, it altered its state. It collapsed its function. So it disturbed the ring system. So, sound does affect. So imagine if you're localizing a high energy beam on a local area, yeah, it could destabilize it. It could even.
How did they know it disturbed the state if they can't listen to it? They had to do it visually somehow to see the disturbance.
Whatever that machine that they used, when they converted it, to see it visually and hear it, there was a difference between the first time that they took the measurement and then the second time. So they knew that they were the cause of that disturbance. That machine was that powerful.
Oh, so the machine had to beam out a laser or something to.
Exactly.
I see. Okay. Well, of course, that laser is going to connect to the ring of Saturn and bring it that vibration through the laser to the planet Earth, and that's going to definitely change the resonance going on with Saturn as a single unit. Once you send a laser out to it connected to another body, then it's not a single unit now. It's 2 units combined. A light may not be a wire or a physical wire, but it's still a connecting medium.
Bernie disappeared on us.
Sorry, just looking for my external hard drive. Just need a minute.
So I've built 4 of the new cells on the new design, and I'm getting about 10.63 volts, and it's been running pretty steady. I took this one off the stack just to measure the power, and I'm getting a steady 2.5 volts out of the cell. My old cells were only putting out about 1.6. These are like almost double the voltage.
And you don't need to feed it no power, just
Very
puts
nice.
out the 2.5. Huh?
Just runs on its own, man.
Nuts. That's the barium titanate.
No barium titanate in this. I can't really talk about what's on the
Graphene.
inside, but it's got a graphite plate. Yeah, that's the main conductor. The charge, whatever charge is coming through that median, is going to gravitate itself into the graphite. So it has capacitive value.
You know what I think's an interesting material along the lines of what I think you're working on, Mike? Pyrolytic graphite. I know you probably looked that up.
Yes. Yep. I already know I know exactly what you're talking about.
It's cool, right?
Yeah.
Yeah, I could see it being useful. Are you?
Well, the
Sorry.
Go ahead.
Are you using? You're not using graphene. You're using graphite.
Graphite. This is a high grade. This is what they use in nuclear reactor cooling systems.
And that's why carbon's so cool, because you could go from graphite to graphene or diamond, which is not conductive at all, but very heat conductive. Or
See, this one. Yeah, what's interesting about this cell is when you put it under a load, the cathode cools down.
Yeah, endothermics.
Yeah, it's a 10-degree difference between the cathode and the anode.
I want to talk to you backstage. I want to say something, but I can't. But yes.
Yeah.
That's
I
why
understand carbon. It has a geometry of the double tetrahedron geometry. Like
it
a
depends
spiral.
on the allotrope, dude. There's like so many allotropes of carbon, and carbon's just miraculous how many things it can do.
So you're saying it depends on the form of carbon and what geometry it has?
Yeah, diamond, is completely different from graphene or pyrolytic graphite, or activated carbon. You know, like there's so many different ways to use carbon.
Yeah.
And it's what you want to focus on is the allotropes, because carbon can be extremely conductive like graphene or a complete insulator like diamond. And between those two, there's so many different ways you can use it. And I would recommend people to look at the carbon cell to understand that further.
But the majority of carbons, even though the geometries are different, they're still relatively spiral. No?
Well, I mean, they're hexagonal, I would say.
Which
They
is
want
still
it
has that angle, that 45 or 9, whatever, 27
maybe.
degree.
I haven't looked at the angle. You might be right.
It's the same angles. So when you think about that angle and you think about how a wave has that angle, so there's waves everywhere. Carbon is, allowing the waves that are everywhere to wrap around itself.
Carbon's a miraculous thing that most people don't get. Water and carbon are carbohydrates, the basis of life on Earth.
Yep.
Like water and carbon are very miraculous. Like so many ways you can take water and carbon, just out of any two elements. It's just amazing.
The fact that diamond's an insulator, which tells me that the carbon in there, the molecules are not aligned.
No, they are. No, they're tetrahedrally aligned.
They are aligned. And how is it an insulator then?
Because it's a thermal conductor, right? So it allows photons to pass, and the cleavage, I guess.
Electrical insulator?
Thermal.
I mean, don't they use diamond in crystal oscillators?
That's quartz, yeah.
I'm sorry, quartz. It's it's similar to diamond, isn't it? Quartz.
Well, that's silicon, not carbon.
It's a carbon. Quartz is a carbon, right?
Silicon. Quartz is silicon.
Silicon. And
silicon dioxide. But it is a semiconductor like carbon. Carbon's in the same, like on the periodic row or a column going down. You got carbon and silicon, and then germanium. So they're in the same semiconductive class.
So diamond's not exactly an insulator then.
Diamond is a carbon-based insulator. It's one of the best insulators against electricity, but it's one of the best thermal conductors. It can conduct heat, but it can't
conduct light too.
Yeah.
Light as well.
To make diamonds, it takes very, very high pressure of physical pressure as well as heat at the same time. That's why diamond has the properties it does.
But it's still carbon. It's still the same thing.
Still carbon, yeah.
It's just tricky.
No, but they have a solution to make diamonds more efficiently using gallium.
That's alchemy, man. I can't say this.
It's material science, right?
Yeah,
I think it all depends on the angle of the carbon.
How about you have a pile of sugar and then you send a balloon up and cause a lightning strike to hit that sugar, and maybe you're gonna get a little bit of diamond out of it.
Yeah, they're combining gallium, nickel, iron, and silicon. Design graphite crucible. Researchers are ushering a new era for diamond production.
Yeah, you can make diamond. Takes a lot of pressure to make it.
Yeah.
No, but like I said, they found an alternative way to do it without high pressure.
What blows my mind? Like ancient alchemist script talk about taking gemstones like diamond and softening them and being able to mold them with their hands and then re-solidifying them.
That's crazy.
Right? Imagine if you could take a big ass diamond or small diamonds and combine them into big diamonds they talked about back in the ancient alchemist days. Bernie should know this.
Can you see my screen?
Absolutely.
I don't.
You remember, like, they would soften gemstones and combine them or shape them, and then after they're softened by that process, they would reharden it, and it would just be like the original. But how we adapted it?
I would like to see that.
Yeah, Mehran Kesh actually talks about it and how you're able to create diamonds through the electrolysis process as well.
I think if you're patient enough, you could.
I saw this video on how they made the pyramids. And the theory was that they built a huge Fresnel lens to melt granite. It was portable, but still a huge one.
Yeah, Fresnel lenses are really cool, though. You can cook with them, like melting stone and stuff, but I don't know. I think
the problem with combining them, you wouldn't know if they're gonna stay clear or they're gonna, like go darker, like the
Yeah,
bond
yeah.
right from the
Well, you would have to like patiently get the distance. Like when it gets darker, just try to level it out and see if it makes the focus better. You know what I mean?
no, I'm
I'm
saying
just
like
gonna scoot out for a quick minute.
like remelting it or combining other pieces into one bigger piece and solidifying it again.
Oh,
Finishing
gotcha.
out, thinking that process. Well, how would you guarantee for it to stay clear?
Yeah,
I
this
think,
is
Lulu,
something
the
that's
clearness
out
is related to the alignment of all the molecules
later.
so that the light can refract without being blocked. If the molecules are not aligned, the light will be blocked. So that's what I think has got to do with the color of the material. Is the molecules, whether they're aligned or not, they're not going to be aligned if there's not a sound wave or something to align them when they're in malleable form. So once you turn the material into a malleable form, it loses alignment. And if you don't realign it before it becomes solid again,
That's why they had to re-solidify it as the next stage.
Yeah.
And I believe some had aspects to do with mercury too, if I'm not mistaken.
Well, at least Bernie knows that I'm not just spitting spitballs for no reason. This is like alchemical text.
Big time.
No, listen, if there's no experimentation with thought of what you could do, then how do you know if something works or it doesn't? You have to first think that you know what, like what you suggested. Yeah, I mean, how would you know if it works or it doesn't?
Absolutely. I mean, until you literally do it, you don't know. So yeah, it really comes down to that, like believing, having faith in
we
it.
still don't know why the sky is blue. We say it's because of the ocean water, but that's
nobody's
not
going to
true.
perform an experiment for no reason. Like they're like, okay, you can't shape this diamond into whatever you want, or combine diamonds into one big ass diamond, because we believe that that's not possible. You know what I mean? But just like sending up two different balloons, any experiment, unless you do it, but they're so cryptic about the way they say to do it, and unless you know the lingo like Bernie does, then you'll never understand what they're saying. It's just cryptic. You gotta know symbols, you gotta know a lot of stuff. But hey, I mean, who's to say that it didn't? Why would they make it up? Is what I'm wondering. So many different resources saying that you could take gemstones and craft them like that. It's just something that, like, if it is made up, why is so many people making this up?
Aren't they doing that with heat though? Temperature?
Maybe.
The current, synthetic diamonds, they're made with high temperature pressure chambers, no?
Yeah, modern ones, yeah.
Right.
But
that's how carbon is turned to diamond under the ground. Pressure and temperature.
Conventionally, yeah. But dude, there's literally this I don't know if I should say this.
Yeah, why not? That's alchemy.
Quit. Foaming. Keep foaming.
You can take carbon dioxide, freeze it, and make dry ice. You can combine it with aluminum powder and make a thermite reaction. In a controlled environment, that reaction will produce microdiamonds. A huge amount of microdiamonds in that explosion. Because when the aluminum reacts with the CO2, it starves the oxygen of the carbon, and the carbon just makes a ton of little bitty diamonds. And what alchemists are saying is you can take those little bitty diamonds and make them into a big diamond. But a reaction is possible on Earth just through they called it a cold thermite, because it's the only time you're using dry ice.
Diamonds, like
it's a thermite
diamonds if you can make them.
I'm just saying, I can make diamonds if you want me to make diamonds.
But if you can make diamonds, you're not going to get rich, because then you made a diamond. That means people can make diamonds now, and they're everywhere, and they're
already doing it now.
I'm not trying to get rich off of it.
Different than cubic.
what's the use of diamonds? You know,
Drill
what,
blades and the hardness.
If,
what are they
di-
using for? You know?
Diamonds
if
are worth
diamonds are not
more
rare anymore,
per
they're
weight
going to lose
than
their
gold.
value.
If you
Are
can
you
make
talking about, like,
diamonds, you would
knives?
make more money than gold off the weight. I'm just saying, if you literally could make diamonds, you would be the richest person on earth.
Yeah,
But
but
I'm
no,
not trying to do that. You know what I
Well,
mean?
right. Let's say they make diamond. They have a use for diamonds. That's why they make them, right? It's not to get rich. It's they have a use for them.
but they are already available. They're called moisanites. They're lab ground diamonds. They're
Yeah, they'll have saw blades that are have these little bitty diamonds that are made by a process
Right.
that I'm
For
telling you.
saws, right?
and
I
they're
know
like
that
a
part, but
price of a
that's
real diamond.
it's
And
cheaper to use synthetic
all
diamonds for that than
But
to use,
you're literally
pressure and
making
all that.
diamonds more easy than gold. I mean, it's worth more than gold in weight.
Okay,
But
so
I'm
the
gonna shut up.
ones that you can create in a lab are good for tools, but diamonds for the diamonds, they have to be natural diamonds. But for tools and experiments,
well, that's
yeah,
one use, cutting blades and all that. But there's got to be
yeah,
more than one use for diamonds. I mean,
synthetic because it would be
space,
a cost effective.
space work,
Yeah, but you're gonna
groundwork, tunneling. Maybe they use them to make these tunnels under the ground. Maybe that's why they make diamonds, because they're making tunnels all over the place, which we know that's happening.
yeah, but it's supposed to be for for use as in building material, not for the use of what tradition holds of what a diamond is valued to compare to one
Yeah,
that is
jewelry or whatever.
made by man versus made by nature. Like the ones that are made by man is good for the building things, but the
I can
ones,
see why people would want to make gold, because it's very useful for electronic devices.
yeah,
Like,
okay, but there
technological.
should be because the value would be different. Do you understand? Like okay, let me put it in this perspective. I'm a girl, right? A synthetic diamond would mean crap to me, although it's a
Right.
diamond, but so the value has a difference on to whom is viewing that. From like commercial use, they don't care. They want the synthetic one because it's cheaper instead of being mined and hard, from
Right.
wherever, like for mass production. Yeah, they would want the synthetic one. They don't care about the natural value of it,
But the
right?
facts are the facts. In the long run, if diamonds are produced like they are today, using them for jewelry is going to phase out. It's not going to be
No,
appealing
I'm not
anymore.
saying for jewelry. No, I'm just saying that natural diamonds, what gives them their value versus the synthetic diamonds? What's the value? Because one is natural, one is man-made in
Right.
a factory. There's not a
Well, if I may say one thing, what would be the difference if somebody did turn lead into gold and say, you know what, this block of gold is made from lead and this block of gold is natural? It's the same question.
There'd be a lot more iPhones.
Yeah, gold is gold. The CERN was able to do that recently. Did you hear
I'm
about
just
it?
saying, you're saying a diamond made artificially has a less value, but they could just hide the fact that it was artificial and say, look, we found this diamond in Africa.
Yeah.
No, you can't hide that. Actually, you can see the difference.
All right.
You can see it under a microscope. What's you call those guys? Jewel smiths, or whatever. They can easily see which one's real and all that. It's got to do with something to do with the I don't know. They can tell though. The clarity, I think, it's not as clear. The synthetic ones are not as clear.
Okay, I will say with vapor depression, like what you're talking about, like the vapor type of diamonds, yes. But the way I talked about it with the thermite reaction on CO2 and aluminum mimics a real diamond, but they're very, very small diamonds.
All right, guys, we're almost at 11:30 here. I think I'm going to square it up. I have to get up pretty early tomorrow. But I'd like to thank everybody that popped into the show tonight. Lulu, Nathan, Philip, Mike, Bernie, and last but not least, Jarvis, thanks a lot. We go live to air again next Friday at 9 o'clock Eastern and 6 o'clock Pacific. And I hope everybody has a great week and productive week. And we'll see everybody soon.
Good night, everyone.
Thank you.
Good night.
Good night.
Much love.
Right.
Stay on, guys.